Have you ever wondered how the universe might meet its end? A question as old as humanity itself, yet the answer remains elusive. As we gaze into the cosmos, we can't help but speculate about the ultimate fate of everything that exists. Scientists, the modern-day wizards of our world, have proposed various theories about how the universe could meet its end. Some point towards a big freeze, others to a big crunch, and a few even hint at a big rip. But among these apocalyptic scenarios, one theory stands out as the most widely accepted: the heat death of the universe. This theory paints a picture of a universe slowly winding down, its energy dissipating until it reaches a state of maximum entropy. It's a concept that is as fascinating as it is terrifying, a silent end to the cosmic symphony that has been playing for billions of years. So, what exactly is this heat death of the universe? Heat death isn't about a fiery end, but rather an absence of energy. Imagine you've got a piping hot cup of coffee in a chilly room. Over time, the heat from the coffee spreads out, seeping into the cooler air around it. Eventually, the coffee cools down and the room warms up a bit, until both are at the same temperature. The heat has dispersed, equalized. It hasn't disappeared, but it's spread so thin it's no longer useful. Now let's think bigger, much bigger. Picture the universe as that cup of coffee. According to the theory of heat death, the universe is also spreading its energy out. Stars, galaxies, all radiating energy into the cold expanse of space. Over unimaginable spans of time, the energy will equalize. There won't be a fiery end, but a slow, gradual cooling until everything reaches the same temperature. Now let's delve into the key points about the heat death of the universe. The heat death theory is based on a few key principles. At its core, this theory is founded on the principles of thermodynamics, which govern how energy moves and changes form in our universe. Firstly, we have the zeroth law of thermodynamics, which states that if two systems are in thermal equilibrium with a third system, they are in thermal equilibrium with each other. This establishes temperature as a fundamental and measurable property of matter. Next, we have the first law of thermodynamics, also known as the law of energy conservation. This principle asserts that energy cannot be created or destroyed, only transferred or changed from one form to another. The second law of thermodynamics introduces us to the concept of entropy. It states that in any energy transfer or transformation, the total entropy of a system will always increase over time. Entropy, in this context, is a measure of disorder or randomness. Now, how do these principles tie into the heat death theory? As the universe continues to expand, it becomes less dense. Energy, adhering to the laws of thermodynamics, becomes more evenly distributed. This process leads to an increase in entropy. The ultimate state of this process is what we call maximum entropy. Here, all energy in the universe is distributed so evenly that no work can be done. No stars can form, no planets can orbit, and no life can exist. This state of maximum entropy, where all is still and nothing can happen, is what we refer to as the heat death of the universe. But let's not get too gloomy. The universe is a big place, and these processes take an incredibly long time to play out. We're talking about timescales that dwarf the age of our solar system, our galaxy, and even the universe itself. So, while the heat death of the universe is a chilling thought, it's not something we need to worry about anytime soon. It's millions upon millions of years in the future. Until then, there's still a lot of cosmic story left to unfold.